All right, so I'm going to take you through how to partition a line segment in a particular ratio. And the reason I have A to B here, that's what it says on your formula sheet. If you were going to take the EOC in geometry, or if you were just going to look at the formula sheet to figure out how to do this. But here's all it means. I'm going to use the ratio 2 to 3. That's just something I made up. But here's how you would read it. That means to go 2 to 3, that's a total of 5 if you add them together. So that would mean take a segment, break it into 5 pieces, and go 2/5 of the way. Since the first number is a 2, you'd go 2, and the bottom number would be 2 and 3 together, 5. 2/5 of the way from the first point to your second point. So visually, here's a segment right here. Okay, and I don't care if you want to think of this like a piece of candy, as anything like that. Okay, money, whatever. If you had this much and you had to break it into 5 equal pieces, hopefully you can see that I did break that into 5 equal pieces. Here's 1, 2, this is my third piece, here's my fourth piece, here's my fifth. So it's now in 5 equal pieces. Go 2/5 of the way from start to end. So if I started to move, 1, 2, I would end up right there. Okay, that is the point that matters to me. Okay, so I did it visually so you could see it, but here's how you're actually going to do it with a formula. Okay, so the formula sheet has this formula on it. It also has another one that's a little bit more complicated, but it also works just the same. But I would just focus in on this one. You're going to use all of these variables. Okay, and so when you hear partition the line segment, x, y in the ratio 2 to 3, your 2 right there is your A. The 3 is your B. Okay, then we're going to go from X to Y. So it does matter that this is my first point. So that's my first X and my first Y. And that over there is my second point. That's my second X and my second Y. So now I'm going to use my formula. So I'm going to start with the first part of the point. bx1 plus ax2 over b plus a. So in the formula, I'm going to replace the b's with 3. x1 was -4. The a's, since I have 2 of them, one here and one here, both of them are 2. So I'm going to replace that. And then the x2 is 11. And I'm just going to start to simplify it. That 3 times -4 is -12. 2 times 11 would become 22. That 3 plus 2 on bottom is simply a 5. I'm going to then add the top together. That becomes 10 over 5. 10 divided by 5 is simply 2. So the x-coordinate is going to be 2. So now I'm going to do the y's. Same thing, start to substitute in your values. The b's become 3. y1 was 1. A is 2. y2 is 6. Plug everything in. 3 times 1 is 3. 2 times 6 is 12. On the bottom, we have a 3 and a 2. On the top, we have a 3 plus a 12. That should become 15 over 5. And 15 divided by 5 is 3. So our coordinate is 2, 3. And you can see from that visual that I did that that point that we actually plotted was at 2, 3. So this is a not real complicated method, but just to give you another problem here, let's say that I had said to do it in a ratio of 1 to 4. Okay. What that means is it would be 1/5 of the way from start to finish. Okay. Visually, it'd be 1/5. In terms of the formula, A would be 1 and B would need to be 4. Okay. So from there, you would just need to fill in the information from the formula, and you would want to, of course, have a beginning point and another end point. Okay, but let's just look at this again. Let's say 5 to 7. Okay, now visually, what this literally is doing is you would break it into 12 equal pieces, and you would go 5/12 of the way from start to finish. But again, A would need to be 5 and B would need to be 7. Okay. And so then from there, you could use your A, your B, you could plug it into the formula. You just need to know what your X's and Y's are from your 2 points. So hopefully this is helpful. You should be able to use this formula right here. If you didn't already, you need to copy it down.